So it comes to the wave of refraction, diffraction, reflection, and wave runoff and sediment transport. So coverage of this topic. The wave is very interesting one. Right? Good for swimmers and windsurfing. Have you had a chance to do such one? Anybody? You should travel in this way. So it comes of because of the energy. We already told that the wind is the first region, but there is also other regions, right? And commonly caused by winds. And wave reflection and shallow water. Wave speed decrease as the water depth increase, then wave break. See from this one shows a water particle movement. So the water particle is rotating, not moving. Water particle is not moving. The wave is moving. Water is only circulating. Not stay there, but almost stay there. But the particle is just rotating. It's moving on, but very slow. Very slow. And if you are net transport of water, and then the shape is changed because of the bottom, right? And then it gives you a elliptical shape. And also, you see that water crest is sharper and higher, right? And then finally break. You already see it from the beach. Far away, you cannot see any wave, right? But when it comes to the beach, suddenly there comes a wave and then break. Why? This is the reason. And you can expect that big waves, tsunami, when you see tsunami in the deep water, you cannot see any tsunami wave. Because it is very big wave, so that the length is also big. Height is also big. Length is also big. So as a swimmer, as a boat riding people, you cannot see the tsunami. But when it comes to the beach, it goes up and narrower and steeper. Then it gives a very 10-meter high wave is breaking down to the town side. The shallow water wave speed decrease as the water depth decrease, then wave break. Because you need to stop there, right? Waves have a speed, but somehow you need to stop it. And it comes to slow down, and then some of the also there should be a friction, bottom friction. It's also another kind of complicated. And also you need to know about this depth length. Depth. Oh, what is this? L is wavelength. You can observe the length of the wave. So half of the length, then there is no wave there, no water particle movement. Right? So that gives you another idea on when the storm is coming. You need to dive down up to half of the wavelength, then what has come there. Right? One idea for the fish farmers. Fish farmers usually have a cage, and they feed fishes there using structure and also some food there to the fish to make them bigger, faster. Right? But storm is coming, the cage can be break or open so that fish is far away. Right? So in that case, they need to pull down to the water depths up to half length of the wave. Then the water is calm, safe area for structure. Other things can be imagined there. And then refraction. Refraction is a bending of wave pressure. Here is refraction, same reflection. Reflection is bending of wave directions. Wave direction. So that wave also speed change of wave with depth. Depth is changing there. Shallow water, frictions from the bottom. So the speed is lower, shape is elliptical. Anyway, so then wave has a different shapes because of the this kind of random shape. When there is a rocks here, then it gives you a sharp corner. And then it gives you a different directions like this. Then it gives you a sediment movement of the other ways. The wave energy converging on headland, it gives you the name of headland, and then quiet beaches. The wave is spreading up, so you can enjoy yourself here. Beach, sand and shallow and calm. So this is very every time I have a class here, I'm confused with these names. Reflection, reflection, reflection. So reflection is easy to remember. Reflect. Reflection is very. Fraction is same. Fraction. Refraction. Diffraction. So the fraction same as change in the direction. Those two are same. But the refraction comes from the medium to another. So air is here, water is here, so that light is going the other direction, right? One example is but diffraction gives you change of direction is same, but it's through the opening hole, small hole, or around the barrier. This is around the barrier. But previous slide is a refraction. So change of direction because of the medium. What medium here? Medium of bottom side, and also effect of this angles. And here, same phenomenon there. And diffraction. Diffraction is through the hole, and around the corner, around the different area. So that there is a circular shape of wave, Wave energy transferred laterally. And this is a breakwater. Or small iron. If you such a phenomenon. Right. Reflection is easier, right? Incident ray and reflected ray. Oh, let's see.
Sun just set, and there's an incredible amount of physics to be learned. Looking at these waves and going through shallow water. what I'm looking at is I'm looking at waves traveling in towards the beach, and then waves reflecting out through the waves that are traveling in. Meaning waves coming in, bouncing off the beach, and reflecting back out. Now, while they bounce back out, you can see the incoming wave interacting with the outgoing wave. What do we call it when one wave interacts with another? Let me think. Wait a second. I think that's called interference.
Right, so wave run up. Wave is coming toward the land side, right? Run up. How much? This is near shore, they are saying foreshore. So the water level should be here. Normal, calm water level. Because of the wave, water is coming up to here. There is a distance, a height, the vertical extent of wave uprush of the still water level. This is R. And beach coastal protection structure need to know about it. Due to this phenomena, probably housing over near the shore can be dangerous. Also, somehow the sediment is moving toward the ocean, then the structure is a problem. Anyway, you need to know about this kind of movement and changes. Sediment transport. So because of this kind of water movement along and around the shore side, the solid material settles down at the bottom of the liquid. But the size is different. Fine sand, the clay is more smaller, medium coarse, and gravel. And so transport. And depending on the size and weight, there is a suspension of clay, grain size, depending on, and also the final one can be a solution into the water. So the color of the water is different due to this kind of solution. All suspension, smaller size, and sedimentation and traction, different names. The natural phenomenon. And there is equations. I cannot explain all this. There is it. Because of the resistance force with inertia, fluid velocity, creating moving force, and then initiation of grain movement. So there's a force equilibrium, and the one is bigger, then it stops to move, right? Same as the fluid drag, lift force, gravity, friction, and then force is equilibrium there. Right? The typical remote condition is gives you kind of criteria that when this sediment can start to move, you need to protect all this kind of functions. And lift comes from the buoyancy, displacement of water. Because this one displaces water, and same amount of water it gives you force feedback. That is the buoyancy. But because the weight is bigger than buoyancy, that's why the stone is at the bottom. Right? As I told you before, that your body Did I told you? No. Yes. Your body is floating or coming down to the bottom. How do you expect your body? Near the surface, down to the bottom. What is your answer? Near the surface, yes. Or down to the bottom. What is your answer? Which one? Down to the bottom. Right? Once again. Your body, when you stay calm, right? What happens with your body? Near the surface. Raise your hand. Near the surface. Near the surface. Down to the bottom. Only one person. It's not easy. Very complicated. Right? So buoyancy is not small. Buoyancy is big. Right? But I know that you can swim, right? You can stay all over the water, at least your head, right? But you're using some energy. But when you are calm state, I will tell you about detail in later stage of this class, the wave architecture part for the moment. So, 새우등뜨기, Korean student. When you start, do you have a class or learning course of swimming somewhere in your career when you are young? Swimming class.
Very
And first skill you learn when you have a class is, I don't know the English name of 새우등뜨기, but you make your body in this shape and then stay in the water, right? That is how in Korean the 새우등뜨기. You tried that, right? Yes? Anybody? You have experience, right? Quick answer. If you usually you have a full of breath when you do that because your head is inside the water, right? Full of air in your lung. But you never try this one without air in your lung and try that kind of experiment. You go down to the water. So your body is near water weight ratio, especially when. So it's not easy. Buoyancy balance and weight balance is for the ship also. So you see, ocean situation. And second transport, there is another video. So let's see. Final. Good. Thank you.
이거 먹고 나서 남자친구 입냄새랑 속쓰림이 사라졌어요.
속쓰림하고 소화
Experiment. Grain size. Grain size. What size flowing? This is just a natural phenomenon, right? You already know about this, but you did not pay good attention to them. But if you go to the coastal engineer somewhere in your lifespan, then you need to know about this, right? Otherwise, your structure, your design can collapse, have a problem. That's why you are learning and studying. Right, that's enough for today. Question? No? So we are just on the schedule? No? Let me just. Oh. All right, see you on Tuesday.